All right, you guys, today we're taking a look at geometric proofs. All right, we're going to take a look at an example here. There's generally 5 parts to every geometric proof. We're going to have some sort of a given idea from which to begin. We're going to have some diagram. Geometry is the study of the physical side of mathematics. And we're going to have something that we need to prove. All right, just like our algebraic proofs, we're going to start with that. We'll generally start with that given statement, and we need to be able to progress all the way to what we're trying to prove. Now, please understand these reasons are not going to be some written out statement. It's not going to be a discussion. Every single one of those reasons must be either a property, a definition, some sort of proven theorem that we've discussed along the way, or some very simple idea that would not require a proof called a postulate. All right. So these the things that the items we're going to use to justify each of these statements, I want you to understand it's got to be something rock solid. All right. And if you go to Schoology, we're in Unit 2 right now. And if you look at even at the very beginning on day 1, I've put these proofs, postulates, and definitions. If you look at the geometric proofs, I'm going to put it there as well. But if you go into here, I've already tried to provide you a list of all of the current postulates, like the segment addition postulate, the angle addition postulate, and a bunch of highly important definitions. In fact, these would be all of the definitions that we could possibly be using in the proofs that you're going to see in this class. So we want to walk through it and kind of look at some of the mental jogging that you kind of need to do. So what I would really recommend, make sure you read step 1. All right. It's very important that you read the statements and you do your best to try and understand what's being said. Even though we know the reason for step 1 was a given idea, let's try and see if we can understand it. PR, they actually meant ray PR. If you look up here, ray PR bisects. Now we need to know. So that was on my list earlier. Bisect means to cut something in half. All right, and angle SPQ. If you don't know, there's actually 3 angles up here. This small one on top, there's a small one on bottom, and then there's the whole thing, angle SPQ. Well, they're saying ray PR bisects the big angle. And if you go, okay, this ray's cutting it in half. I know if I cut something in half, I end up with 2 equal pieces. Well, look at statement number 2. They're saying angle RPQ. RPQ, that's the bottom angle. They're saying that has to be, this is the symbol for congruence. It has to be congruent to RPS. RPS is the top angle. Well, why are those 2 angles? Why do they have to be the same? Well, it comes from this word. We just said if we cut an angle in half, then the 2 pieces have to be the same. We know they have to be the same. We're using that word. If we're using that word, what we would write down, that's because we know the definition of the word bisect or bisector. I'll just leave it as bisect because that's the word we used in step 1. We're using justifications, and all of our justifications have to be this kind of an item, not a maybe, not a discussion, not just because that's the way it is. Okay, now let's see where this moves, because this should all be a conversation, almost like a courtroom proceeding. Somebody's recording our discussion. Well, they went from RPQ as congruent to RPS, and the only change they've made now, instead of saying congruent, now they have equality. The measure of angle RPQ better equal the measure of angle RPS. Well, I want to give you this one because this is used every now and then, because step 2 is talking about the geometric objects are the same object. Step 3 is transitioning. We're talking about numbers now. We're allowed to go in and out of that conversation. That's called the definition of congruence. That's what congruence means. You need to know that when you're going to see that one in this course more than just today. Okay, we're doing fine. We have two congruent angles. That means their measures are equal. Now let's try and understand. Step 4 says this looks a lot different. The measure of RPQ, that's the bottom angle, plus the measure of angle RPS, that's the top angle. The bottom angle plus the top angle has to equal SPQ, that's the entire angle. Interesting, the bottom angle plus the top one equals the whole thing. Well, that sounds pretty simple. If you look back at the page that I had just given you, that's called the angle addition postulate. Now here's where this gets good. Step 4, man, changing step 4 into step 5, they look almost the same. You got to say, well, what changed? They still got RPQ, that didn't change. They still got SPQ over here, but angle RPS, they changed it into RPQ. And you want to think in your head, should they be allowed to do that? And the answer on these proofs is always yes. I'm not going to try and trick you. Now, they can replace RPS with RPQ because in step 2 and 3, we said that they're the exact same. If they're the exact same, I can take one out and I can put the other one in its place. We're replacing something. That's called the substitution property. All right, now if we look at step 6, how did we go from step 5 to step 6? Because this has all got to be connected. Certainly at the end of the proof, we had RPQ plus RPQ, and now they have 2, and I'll tell you, there's a typo here. This is supposed to say RPQ. Wish I would have cleaned that up before I started this. So if I had RPQ plus RPQ, can we combine them and say that's 2 RPQs? Sure we can. That's called simplifying one side of an equation. It's not the addition property. We did not add something. The right side of the equation has not changed, so that's not the addition property. That's simplifying, or sometimes we call that combining like terms. Either of those ideas would be just fine. So please try and understand. Part of the big idea is make sure you're reading these steps and trying to understand what's going on. And make sure you're justifying using one of the rock solid items that I've provided in class. If you do that, there's not a proof up here that you can't do.